Welcome to BCIS 1305. This is Dr. Schuessler again, and today we're going to be looking at Chapter 11, Information and Data Management. So before we dive on in here, let's go take a look and see what the breakdown of the topic is. We'll start out, we'll talk about the term database and what it is, what it means, and the relationship that it has with data and information. We'll talk about the term data integrity and why that's so important to a database and how that impacts the information quality of a database. We'll talk about the terms character, field, record, and file and how each of those are related to one another. We'll talk about file maintenance techniques and validation techniques. We'll differentiate between file processing and the database approach. These are different approaches, and we'll talk about and distinguish between those two. We'll discuss the functions common to most database management systems. A lot of them have a lot of similarities, though they may be different from one system to the next. They, to a large degree, have a lot of the same characteristics. We'll talk about the characteristics of relational, object-oriented, and multidimensional databases. We'll talk about web databases. We'll talk about database design guidelines and understand the responsibilities of database analysts and administrators. And then the chapter finishes up talking about information systems in enterprises and what some of those different systems look like and what the functions are and the purposes are behind them. So let's go ahead and jump on in. So a database is a collection of data organized in a manner that allows access, retrieval, and use of that data. So data can be a variety of different things. It can be text, it can be numbers, it can be images. So a database is a collection of those different pieces of data organized in such a way that now it becomes useful, it becomes meaningful. So the database helps us to present that data in a meaningful, organized way so that we can use it for some purpose to be able to make decisions or whatever. So the example they give here in the text is collecting information from a student. So we may want to collect their image, we want to collect information about who they are, their name, their address, their contact information, and it allows us to store that information, and then we can process that and produce it in terms of output in a variety of different ways. We can produce reports, we can produce ID cards, etc. So database software, sometimes referred to as a database management system, is what allows us to work with and manipulate the database. So it's what allows us to actually create the database in the first place. It allows us to create, modify, and delete data in that database. It allows us to sort and retrieve data, so to be able to manipulate that data so that we can look at it in different ways and retrieve that information. And it allows us to create different ways of presenting that data in terms of inputting data into a form, or observing or looking at data in a form format, or to be able to print it out in the form of a report. Now the data that goes into that database is the quality of that data is really very important, because the information that's based on that data, if the data is incorrect, that information is going to be incorrect. And so this is something that's referred to as data integrity. Data integrity reflects the quality of the data that's in that database. So if we have bad data, we're going to end up having bad information. So the more errors that data contains, the lower its integrity. So we want to have high integrity in that database. Data integrity is important because computers and people use information to make decisions and take actions. If you're going to take an action off of bad data, chances are pretty good that your action is going to be a poor choice. This is as far as the relationship between data and information. Remember, information is data that's organized in a way that makes sense, that allows us to context or more meaning behind that data. So valuable information should have the following characteristics. It should be accurate, it should be verifiable, it should be timely. In other words, good information that's late is not good information. It should be organized, it should be accessible, we need to be able to get to it, it should be useful, it should be cost effective. Not all information is worth it. So how is data organized in some sort of a database? Data is organized typically in layers. So the example here that they give us is a school database. And in a school database, we may have a variety of different things that we want to keep data about or information about. So students, for example, instructors, classes, student schedules, for etc. So a variety of different things that we want to keep data about. If we look at dive in a little bit deeper into the instructor file, for example, we'll see that we have a variety of different records, and a record is a collection of fields, and we'll talk about this a little bit more here in just a second. But it's a collection of fields about a specific record. Or about a specific student. So for example, we may have or in this case, an instructor. So in this case, we have an instructor ID. We have the instructor's first name, the instructor's last name, their telephone extension, their office number, and their email address. So these are all related pieces of information about a single instructor, and that represents a record. The instructor ID is a field, so we have multiple IDs to represent different instructors. The field instructor ID is a field. We have a first name field. We have a last name field. So together these all represent the instructor file. So how do we build up all that stuff? Well, let's start at the very smallest and the very lowest layer that we can. We start out with a character. A character is represented by a single byte, and it can represent numbers, it can represent letters, spaces, punctuation marks. The key is it's going to represent one individual character. Now that may be enough to be a field. For example, if we have a field that's indicating gender, for example, the field is gender, and if we want to limit it to M for male and F for female, that's a single character, and it also represents a field. But typically a field is going to be larger. We're going to combine multiple characters to represent a field. And that field's going to have various characteristics. It's going to have a field name, it's going to have a field size, it's going to have a data type. So for example, if we come over here to the instructor file, we're going to have a field called instructor ID, and the data type is going to be text. Same thing for first name, text, last name, text. The extension number is going to be a number, so it's a different type of data type. We expect it to be a number in that field. So those are some examples of a field. Common data types include things like text, numbers, those are the easy ones, but there's also auto numbers if we want to create some sort of an automatic number that we know is never going to be duplicated, which is important. We'll talk about that a little bit more here in a minute. We can use the auto number data type to be able to do that for us. Another data type is currency, hyperlinks, Boolean operators for yes or no. They could be like checkboxes and things like that, or true and false. Memos, which are really text fields but larger. You can input more text into those fields. Dates, objects, and attachments. So there's a lot of different types of data types, and appropriately creating fields with the appropriate data type help us to maintain some of that integrity that we were talking about earlier. Moving above the field level, we start to combine multiple fields that are related to each other, and it becomes a record. So in this particular case, for student ID 2295, related to that student ID is that student's first name, that student's last name, their address, city, state, etc. So all those are related fields, and therefore that represents a single record. Now we need to be able to identify that record uniquely, and there's several different ways we could do that. We could use somebody's last name, for example, but what happens if we have another student with the last name Brewer? We have, say, somebody named Mike Brewer. Maybe it's brother or something like that. If that's the case, now all of a sudden we have two Brewers, so it's not a good primary key. It's not a good unique attribute about that particular record. So if we have to identify that specific record, we need to pick something else. If we do that, we can use that auto number data type that we were talking about a little bit ago to automatically generate a number, and that way we make sure we never have a duplicate number. And so that's where that comes into play. And so now we make sure that we have a unique record for that to represent each and every student. If we have a collection of related records, in this case different students, now all of a sudden we have a data file. It's a collection of related records. Once we've got our database in place, we need to be able to do some sort of file maintenance. These are procedures that allow us to add records. So if we have students that are coming into the university, new freshmen, we need to be able to add those records to our database. If we have students that move or students that graduate, we need to be able to modify those records to be able to reflect new addresses, for example. Or if we have a student that drops out, perhaps maybe we need to be able to delete that record. So different things that we need to be able to do to be able to properly maintain records in our database. So these next few slides, that's the process that they're going through. They're describing here adding records to our database, modifying those records, and then ultimately deleting those records when they're no longer necessary. So to be able to maintain the validity or the integrity of our data, we can use a process referred to as data validation. Validation compares data with a set of rules or values to find out if the data is correct. So there's a lot of different checks that we can do. For example, we can have alphabetic or numeric checks. So if we have a field that's supposed to be a number and alphabetic characters are entered, it will give us an error. It'll tell us, hey, wait, this is supposed to be a number. This is what I'm expecting. And that's a way to improve the integrity of the data in the database. We can do a range check. So if we're expecting a value between 0 and 100, if we get 200, we realize it's probably a typo that needs to be corrected. It's consistency checks. So for example, we have a student that graduates. Their graduation date must be after the date in which they entered the university. It's simply a consistency check to make sure things are in order. Completeness checks, check digits, as well as other types of checks that we can do to try to increase the integrity of our data. So up until this point, we've really talked about databases in a very broad and general sense. The reality is databases have been around for a very long time. Excuse me. Databases have been around for a very long time. If you boil it down to its very simplest form, a filing cabinet with different drawers that are labeled and different hanging file folders within that file folder or that filing cabinet represents a database. We're storing information. Now, the downside to the traditional file processing system approach is that it tends to have a data redundancy issue. In other words, we have the same information represented in multiple places. So think about an organization such as the university where you have a student that works for the university, but you also have a student that actually is taking their classes and all that kind of stuff. Well, if the student goes and updates their record for the HR department to indicate a change of address so that they can continue to receive their paycheck, that's great until they go to graduate and the registrar's office wants to send them a notification that says they can't file for graduation because they have a fine. Because we have data that's stored in two different places, unless that address is updated at both places, we have inconsistent data. And it's inconsistent data because it's redundant data. So that's a problem with the file processing system. A database approach, on the other hand, takes a different approach. It really tries to reduce the real purpose behind it. The goal behind it is to reduce a lot of that redundancy so that we have data represented in a single place. So when we have a person's address on file or in our database, that student's information, that address is located in one place, so that when HR updates it, that update is also reflected in what the registrar's office sees at the same time. So that's one of the big purposes behind the database, is to help reduce a lot of that data redundancy and thus help to improve our data integrity. So this is what it might graphically look like. If you have a schedule of classes here on the left and you have an instructor file there on the right, as a student, when you go to register for a class, you kind of want to know a little bit about the instructor that's teaching it. You want to know who they are, their name, all that kind of stuff. Maybe you want to know where they're located and how to get in touch with them in case you have a question about the class. And in a file system, this is kind of how that would look like. You've got all that information located there in your schedule of classes. At the same time, the instructor file has that same information. So we end up with a case of duplicate information. In a database example, though, we still want to be able to have that same capability in the schedule of schedule of classes. We want to be able to see the instructor's first name, their last name, all that kind of stuff, in case we have a question about the class. But rather than storing that information in the schedule of classes, what we do is we actually link it back to the instructor file. So the information is stored only in one place. It's stored in the instructor file. But as a student, when you look up that information, you see the link, so that information is populated from the link itself. And that's the big difference between these two approaches. A data dictionary is another term you need to be familiar with when we talk about databases. This contains data about each file in the database and each field in those files. So for example, if we're looking at a specific field state in this example, we know that it's a data type of short text, but we can be more specific about that particular field. For example, we can limit its size, we can create a format, we can have a caption, we can have a default value. So there's a variety of different things, and this represents our data dictionary. It's defining how our data is going to look. Database management systems also provide you with a lot of other tools that allow you to manipulate the database and retrieve information from the database. This includes query languages, query by example, forms, and reports. So query language is really at a high level pretty simple English-like language, programming language, that allows you to input data into the database or pull data out of the database in a variety of different ways. And as far as the queries themselves, as long as they're fairly straightforward, fairly simple, they are very easy to interpret. It's a structured query language. It is the most common, and you'll see a lot of commonality from one database system to the next in terms of their implementation of SQL. So usually once you learn SQL, you can usually move from one database system to the next and be fairly productive in it. Other databases kind of have their own extensions. For example, Oracle uses PLSQL, which uses standard structured query language, but also has their own little additions to it to increase the functionality. Also, databases provide other tools that really try to help non-technical users through the steps of creating a query. So for example, Microsoft Access has a query wizard. It kind of walks you through some of the steps of creating a query. So for example, you can start the wizard, you can select the table that you're trying to pull data from, you can select the individual fields that you're interested in retrieving, you can go ahead and move through that process. And then if you actually look at the SQL code that's generated from the wizard, you'll see that it's really pretty straightforward. Select, so what are we going to select? We're going to select the fields first name, last name, and email address. So those are the fields we're selecting from the student table. So that's pretty easy, pretty straightforward, and the results end up looking like that. Like I said, these are pretty easy. As long as it's a pretty easy query, those are pretty easy to interpret. They can become much more complicated though. Another tool for building queries for those that aren't necessarily real programmatically inclined, there's also something that's referred to as query by example, which is a feature that has a graphical user interface to assist users in creating queries and retrieving data. Something else you can use a database management system for is to create and work with forms. A form is a window on the screen that provides areas for not only entering data, but also modifying data in the database and being able to view information in your database in a real nice graphical user interface type environment. Allows you to deal with one record at a time for the most part. You've also got report writers built into most database management systems that allow you to design reports to be able to easily be shared and printed out for that type of output if you want it. Other functions of a database management system allow you to restrict access or control the access privileges to that database. In other words, if you have some users that only need to be able to to view certain records or certain tables, you can restrict that access using the database management system. Database management systems also provide a variety of tools to be able to back up databases and restore them, keep track of who's accessing what, when, through a log, things like that. So the database management system is really the tool that we use to be able to interact with that database. Now, a data model defines how users view the organization of the data, and so depending on your perspective, you may refer to a lot of these things differently depending on the perspective that you're coming from. In the file processing environment, we looked at files, we looked at records, we look at fields, and those all have equivalent terms in database terms. If you're a relational database user, a file is represented by a table, a record is represented by a row, and a field is represented by a column. On the other hand, though, if you're a database developer, a file or a table is referred to as a relation. A row or a record is referred to as a tuple, and a field or column is referred to as an attribute. So sometimes you'll see these terms intermixed or used depending on the individual. They all represent the same things. They're just, it's a different perspective of the same concept. So whereas earlier we were talking in very general terms about file systems versus database systems, when we shifted over to talk about databases, we talked about databases in a very general sense as well. The next couple of slides talk about specific types of databases. By far the most common type of database is a relational database. And a relational database stores data in tables. It consists of rows and columns. Each row has a primary key, which is used to uniquely identify that specific record. And then each column has a unique name. In other words, you can't have two fields in the same table with the same attribute or the same kind of field. We need to be able to relate tables to one another, so that's where the concept of a relationship comes into play. And I know it's probably a little difficult to see here. I'll zoom in here. But we'll see we've got a relationship between, say, the student and the student's schedule. So the student schedule has a foreign key called student ID, and that has a relationship to the student table, also the primary key of the student table, student ID. So that's how we can uniquely identify and say that the records in the student schedule with the same student ID as the student ID over here, those are the same. Those are the equivalent information. That's the information that we need to be able to look at. Same thing over here. We see relations between these two tables, relations between these two tables. On this side we have our primary key, and on this side we have a foreign key. And that's what allows us to be able to pull the related records up. Another type of database is known as an object-oriented database, and this stores information or stores data about objects. And so this is great when we're talking about media, when we're talking about images, we're talking about photos, we're talking about videos or songs. Object-oriented databases are great for that because it allows us to store information about objects in a very efficient way. So it's good for other types of data as well, CAD drawings, for example. Yet another type of database is a multidimensional database that can store information in more than just two dimensions. Graphically, it's pretty easy to kind of interpret what we see here on the right as being three-dimensional. We can see height, width, and depth to that. In a multi-dimensional database, we can have actually more dimensions than that, so they can become very complicated. But this really gives us a huge advantage when we start talking about data warehousing, for example, and data marts, where we have lots and lots and lots of data over long periods of time from lots of different sources, and we need to be able to analyze that. This is where the multi-dimensional database can be really very useful. So other databases include web databases. If you've ever Googled something, you've used a web database. The results that are returned from a Google query are coming to you from Google's databases. They've classified all that information and they're returning those results to you. So when you go to these, monster.com, for example, or you go to American Airlines or Southwest Airlines or something like that to get information about flights. So all of those different tools are pulling information out of a database and returning the results to you. So even though you're just working with the front end, you're just working with a web browser, the results, the content of the results is coming to you through the web browser, is coming from a back-end database. So everybody interacts and everybody works with databases, even if they don't realize it. So who manages these databases and works with them and keeps them up and going and creates them and all that kind of stuff? Data analysts and database administrators. Data analysts may not even be all that technical of an individual. They may spend most of their time focusing on talking to people to figure out the processes that are occurring in an organization. They may look at a lot of things like receipts and invoices and all that kind of stuff to figure out what kind of data is being generated and needs to be tracked. They may spend a lot of time talking to HR to figure out who needs access to what pieces of information. And so they spend a lot of their time designing the database and designing what it's going to look like and how it's going to function. They may or may not be all that technically oriented. In a smaller organization, they would certainly have more of those technical responsibilities. But in a really large organization, they may actually have a programmer that's their job, is to implement what the database analyst actually creates. The database administrator, on the other hand, really handles the day-to-day operations of the database. They're going to create queries, for example, and modify queries based on what users need. They're going to help monitor the performance to make sure that database continues to function as smoothly and efficiently as it can, especially as it starts to fill up. Some of those tasks become more important. They're going to help back it up and make sure that the database is properly backed up so that it can be restored if need be. Both of these job functions extremely well paid, very lucrative field to get into if you have an interest in that kind of stuff. At this point, the chapter shifts gears just a little bit and starts to talk about information systems that are typically seen in larger organizations. And I think the reason behind this is that databases are operating on the back end of all of these systems. These systems are the front end that users tend to see, but the reality is there's a back end of these systems that includes a database that's feeding information to these systems. So in general, an information system is a set of hardware, software, data, people, and procedures. So the first half side is really the IT side, the hardware, software, and data. And the people side is people and procedures. Procedures are essentially software for us as people. It tells us what to do, the order of things to do. And data is what really ties us together with the hardware and software. So the first information system we're going to look at is an ERP system. An ERP system really operates at an organizational level, spans a very large organization, and helps them to operate on a common set of data. So it links everybody together using that same data. So when you update an address for an employee, for example, in the HR department, that address update is also reflected for the production manager. So the production manager, when he goes to schedule you for work, has the proper contact information for you. So you're operating off a common set of data. ERP typically is based on industry best practices. So a lot of times when an organization implements ERP, they have to modify some of their procedures to be able to work with the ERP system. But it's typically going to be something that's reserved for large organizations. They can be very expensive, time-consuming to implement. But the advantage is you're, again, working off that very common set of data across the organization. So this is kind of what it might look like graphically. You'll have different organizations within the department or within the organization: HR, marketing, sales, accounting, and finance, customer service. They're all operating off the same set of data so that they can hopefully have a more consistent and clear view of their world. If you have a lot of documents that you deal with, you may need a document management system. A lot of those documents, again, are stored in a database. You may store, depending on the type of organization, word processing documents. You may have presentations that you're storing, spreadsheets that you're storing, video files, photos. There's a lot of different types of documents that you might be storing. There's also, kind of related to this, content management systems. You may have a website that you frequently are publishing different stories to. You may need to manage that content in a very specific way, such that certain stories are published at certain times of the day, in a certain order, things like that. And that's where a content management system comes into play. Again, all of that information in the content management system is stored in a back-end database. Perhaps the most important system that we have in organizations is a transaction processing system. We need to be able to make money. We need to be able to process transactions to be able to make sure that we're collecting money from our customers, that customers are receiving their goods or services, and we need a transaction processing to be able to make sure all that happens the way it's supposed to. What makes a transaction processing system so valuable is that we also collect an awful lot of information when we perform a transaction. We're collecting, for example, customer information. We're collecting information about when they made a purchase, where they made the purchase from, what products they purchased. So we collect a lot of very valuable marketing information as well. It allows us to interact with our inventory management system as well. So a lot of our systems throughout an organization are affected by what happens in our transaction processing system. Very, very important system. Something else in the text that is discussed is that some of these systems are relevant to different levels within an organization. So for example, this slide's talking about management information systems. And this is an information system that's really geared towards upper management, and it's designed to help them make better strategic decisions for the organization, to help them to be able to make those good decisions and solve problems. It's really designed for upper management. This is as opposed to something like a decision support system, which is really designed more for mid-level managers to help them make decisions that are more tactical in nature, more day-to-day in nature. So for example, if you need to reorder supplies to be able to keep your production line going, or to help you schedule workers, this is more along the lines of what you might see a decision support system used for. An expert system is a type of knowledge management system designed to capture the knowledge that an expert might have. A good example of this that I used in class was WebMD. It allows you to capture information from experts, in this case physicians, that's their field, that's their area of expertise, and therefore by capturing it in a system, we can share that information with people who aren't experts. As I mentioned in class, if you stub your toe, maybe WebMD is a great place to go to, what should you do to treat a stubbed toe. But if you have a heart attack, probably not the best place to go. Go see an actual physician for that kind of issue, and an actual doctor. Go to the emergency room. But an expert system allows you to capture some of that information to be able to share it with people who are not experts in that particular area. So in this chapter, we talked about data and information and how they're valuable assets to an organization, how they help you make decisions. We talked about methods for maintaining high-quality data validation, for example. We talked about assessing the quality of valuable information, so making sure that it's timely, for example. We talked about the advantages of organizing data in a database, and we talked about some of the different types of databases. Relational databases, for example, multidimensional databases. We talked about the roles of database analysts and database administrators, and how what their role is in terms of designing the database and maintaining that database on a day-to-day basis. We talked about database design guidelines, and we talked about information systems used in an enterprise, and a variety of different types of systems, all of which have some sort of a database on the back end of those systems. So this is a really good chapter about databases, about information. So take a look through the chapter, be sure and read it. If you have any questions, send me an email, follow me on Twitter or some of my other social media sites, and keep in touch. So take care.